Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 8, string to integer atoi. This is a classic interview question, and understanding it will significantly boost your coding skills. The problem statement is simple. We're given a string, and we need to convert it into an integer. Sounds easy, right? But there are some tricky edge cases we need to handle. We need to consider whitespace, signs, plus or minus, potential overflow, and non-numeric characters within the input string. The constraints are pretty standard. The input string can be quite long, and the resulting integer might be outside the range of a 32-bit signed integer. So we need to be mindful of potential overflow issues and handle them gracefully. This is a great problem to practice your attention to detail and robust code design. We'll explore different approaches, starting from a simple brute force method and then moving towards an efficient solution. Let's dive in. Understanding with examples. Let's clarify things with some examples. If the input string is 42, the output should be 42. Simple enough. Now consider shift-42. We need to ignore the leading whitespace and return -42. What about 4193 with words? We should only convert the numbers until we hit a non-numeric character, so the output would be 4193. Let's consider another one, words and 987. In this case, we should return 0, as the first character isn't a sign or a digit. Finally, let's tackle overflow. If the converted integer exceeds the maximum or minimum value of a 32-bit signed integer, we need to return the maximum or minimum integer respectively. These examples highlight the various scenarios we need to handle in our solution. Let's move to the next stage and discuss the brute force method. Brute force approach. A naive approach would be to iterate through the string character by character. We'd first remove leading whitespace, then check for the sign. Then we'd accumulate digits until we encounter a non-digit character. This approach is easy to understand, but has inefficiencies. The time complexity will depend on the length of the string. We might process the whole string even if it contains only a few digits, making it inefficient especially with extremely long strings. The space complexity is constant, as we are not using any extra space proportional to the input size. While straightforward, this approach isn't optimized for performance. Therefore, let's discuss a more efficient solution. Optimal solution. A more efficient and optimized approach involves a more concise algorithm. We'll still iterate through the string, but we'll do it more intelligently. We'll handle whitespace and sign in the beginning. We'll use a variable to accumulate the resulting integer. Crucially, we'll incorporate overflow checks during the accumulation process rather than at the end. This helps us avoid unnecessary processing. This means we won't need to process the entire string once we encounter a non-numeric character or if an overflow situation occurs. By making checks at each step, the algorithm becomes more efficient and less prone to errors. We can combine this with a state machine to handle different scenarios gracefully and more efficiently. This approach leads to improved time complexity and a more robust solution, eliminating the need for additional processing steps. Code implementation. Let's see the code in Python. We'll implement the optimized approach. First, we'll handle whitespace, sign, and overflow. Then, using a loop, we'll convert the string to integer, and we'll also implement checks within the loop to handle overflow and non-numeric characters. We'll return the accumulated integer. The code demonstrates the approach that we discussed in the previous scene. The key is efficient handling of the character-by-character conversion and checks during the process. This makes the code efficient and addresses edge cases effectively. We'll carefully handle each step to prevent issues and make our solution more robust. The code is concise and easy to follow. It uses Python's expressive power to create a clear and readable implementation. Time and space complexity. Now, let's analyze the time and space complexity of our optimized solution. The time complexity is O of n, where n is the length of the input string because in the worst case we iterate through the entire string. The space complexity is O of 1, as we're only using a constant amount of extra space regardless of the input size. This is significantly better than the brute force approach, which also had a time complexity of O of n, but potentially wasted processing time. We've improved efficiency by optimizing our approach and handling edge cases more effectively. Engagement break. So, there you have it, a complete walkthrough of the string-to-integer atoi problem. Before we wrap up, don't forget to like this video if you found it helpful. Subscribe to the channel for more LeetCode tutorials and algorithm explanations. And let me know in the comments if you have any questions, suggestions for future videos, or alternative solutions you've tried. Your feedback is super valuable to me. Conclusion. In this video,